Hello viewers, I am Dr. G. Littleflower, faculty from the Department of Physics, Stella College. I am so excited to discuss a short topic from physics. Anyone, whether non-science or non-physics persons, can easily understand this topic and you will definitely appreciate the applications of it. Let me discuss polarization of light. The whole world can be categorized into two entities, light and matter. The sun, stars all give us light. Everything else in the world can be taken as matter. The study of light is so fascinating. It reveals the fundamental nature of the universe from the tiniest particles to vast cosmic phenomena. Light connects diverse fields like physics, biology and technology, impacting everything from vision to communication. Understanding light allows us to explore the world and harness the forces that shape our world and beyond. Light interacts with materials and the environment through various phenomena. Reflection. Light bounces off a surface such as a mirror at the same angle at which it strikes. Refraction. Light bends when it passes from air to water medium or glass medium, causing objects to appear distorted. Diffraction. Light bends around obstacles when passing through narrow openings, creating some patterns. Interference. When two or more light waves overlap, they combine to form constructive or destructive interference. Polarization. Light waves, when passes through certain materials, are restricted to vibrate in a single plane, reducing glare and enhancing clarity. Dispersion. Light splits into its constituent colors called spectrum when passing through a prism, producing a rainbow effect. Scattering. Light spreads in different directions when it strikes small particles, causing phenomena like the blue sky. Absorption. Light is absorbed by a material, converting that energy into another form of energy like heat. Among all these 8 phenomena, today let me discuss one of light's phenomena called polarization. Before that, let us know what is light. Light is an electromagnetic wave. It consists of two perpendicular components, the electric field and the magnetic field. These two fields oscillate perpendicular to each other and to the direction of wave propagation. You can see here the electromagnetic wave can be depicted by this is the electric field and this is the magnetic field. The electric and magnetic field will vibrate perpendicular to each other and also to the propagation direction. When we talk about phenomena of light, we focus on the electric field component of the electromagnetic wave only and ignore the magnetic component generally. Why? This is because the electric field interacts more strongly with matter, particularly with charged particles like electrons in atoms, influencing how light is absorbed, reflected, refracted or polarized. Optical devices such as lenses, cameras, polarizers and most optical instruments primarily respond to the electric field component of the light waves. Even our eyes is sensitive to the effects of electric field and not to the magnetic field. The magnetic component of electromagnetic wave is much weaker compared to the electric field component. Its influence on light-matter interactions at optical frequencies is generally negligible and not considered for studying light's behavior. So, when we represent now light, let us take the electric field component alone. Now let us say what is unpolarized light. Sunlight and every other form of natural and artificial illumination producing light waves whose electric field vectors vibrate in all planes that are perpendicular with respect to the direction of propagation. This is called unpolarized light. That is, natural light or light produced in artificial means, the electric field components of that light wave will be vibrating in perpendicular direction as well as perpendicular to the direction of propagation. This is what called unpolarized light. The unpolarized light can be represented like this. You can see the electric field component vibrating perpendicular to each other like this. In the most simple form, we can consider only two types of vibration. One is represented by double arrow headed and the other one is dots. Let us say the double arrow lines, those vibrations are perpendicular to the plane of the screen, and the dots are the vibrations which are perpendicular to the plane of the screen. Now what is polarization? The transformation of unpolarized light into polarized light is called polarization. When light passes through a polarizing filter like quartz, tourmaline, nickel, calcite, such crystals, even sunglasses, camera lenses, only the waves vibrating in a specific direction pass through it. That is, electric field vectors parallel to the specific direction alone will be allowed to pass through it. Then the light is called polarized light or plain polarized light. It contains vibration only in one plane. So this represents the unpolarized light having vibrations in all directions like this. Now we have kept a Polaroid which could be made of quartz or calcite or tourmaline. Here the chosen direction is marked by a vertical line. This generally we call this as the optic axis of this crystal. It's a direction. So when the unpolarized light is allowed to pass through this Polaroid, the vibrations which are perpendicular to this specified direction alone will be allowed to come out of it. So these vibrations are called plain polarized light. Thus, by using a thin film of Polaroid, unpolarized light can be transformed into plain polarized light. This is what called polarization. Now, let us discuss the methods of polarization. There are so many methods, but we are going to discuss only 4 methods: polarization by transmission, by reflection, by refraction, and by scattering alone. Here let me show some pictures which will help us to understand this. So in the first picture, the light beam is having vibrations in both directions perpendicular to each other, and that is made to pass through the polarizer. Now you can see the specified directions called optic axis or vertical. So among these vibrations which are parallel to these specified directions alone will be allowed to come out of the Polaroid. This is transmission. That means from this side through the Polaroid it passes and coming to this side of this Polaroid. So it is getting transmitted, entering as a unpolarized light, leaving the Polaroid crystal as a polarized light. The next one is polarization by reflection. So here you see the incident light. It is having both type of vibrations, parallel and the perpendicular vibration. When it strikes a special type of glass, the incident ray gets reflected and refracted. It can get reflected and refracted. The reflected ray contains the vibrations which are perpendicular to this plane of the screen, and the refracted ray has the vibrations parallel to the plane of the screen. Thus, polarization is done by the method of reflection as well as refraction also here. In the third diagram is purely because of refraction. The incident light has vibrations, both perpendicular vibrations, both perpendicular and the parallel vibration. It is striking a polarizer. Now it gets refracted into two lines. So this such type of crystals, later we will come to know that doubly refracting crystals. So this is by refraction. You can segregate two refracted rays having vibrations. One is having vibration parallel to the incident light, other is having vibrations perpendicular to the incident light. The next picture tells us whenever light strikes a material molecule, for example H2O, you can see sometimes the light just passes through it. That is what we call it as Rayleigh scattering. Sometimes this incident light gives little energy to the electrons of the atom and travels back in the other direction. The incident light color is green. The light that is recoiling having different color. That indicates, the change of color indicates that this light photon has shared its energy or absorbed energy from the atom of the molecule. One more picture to tell how light interacts with the material molecules. You can see the incident light is having vibrations in all directions. So some of the incident radiation can come out having vibrations in all directions. It is transmitted through the molecule of the medium. But if you view in this direction, you can see the wave is having vibrations only in the vertical plane, and view in this direction, you can see the wave coming out of is having vibrations in the horizontal directions. So these are the four methods by which light can be polarized. Now let us see which is called polarizer and which is analyzer. So in this picture, you can see the incident light having vibrations striking the first polarizing film. Now you can see the specified direction called the optic axis. They are vertical lines. Now when the incident light passes through the polarizer, you can see those vibrations which are parallel to this optic axis alone allowed to come out of it. So you can see the unpolarized light while passing through the polarizer is becoming a plain polarized light. So the sheet, the polarizer, that converts unpolarized incident light into a plain polarized light is called a polarizer. The thin sheet made up of special material which converts the unpolarized light into a plain polarized light is called polarizer. Next, what is an analyzer? Now, in the path of this plain polarized light, we keep one more polarizer. This is also polarizer. But this polarizer is going to analyze whether the light that incident on this polarizer is plain polarized or unpolarized. You can see the second polarizer, the chosen directions are in the horizontal direction, that is perpendicular to the first polarizer. That means the vibration, the plain polarized light is having vibrations in the vertical direction. But in the second polarizer, the chosen direction is in the horizontal direction. So they all will be stopped. So no light comes out of the second polarizer. Thus the second polarizer is analyzing whether the incident light is plane polarized or unpolarized. If it is unpolarized, then definitely some of the vibrations will pass through the second polarizer also. But from the figure, we find that the second polarizer, which is acting as analyzer, is not allowing any of the vibrations to pass through it because its optic axis is perpendicular to the vibration of the incident light. So the second polarizer is called analyzer because it is analyzing whether the incident light on it is plane polarized or unpolarized. Thus it is called a analyzer. So a polarizer can act as an analyzer and analyzer also can act as a polarizer. The first polarizing film, we call it as a polarizer because it transforms the unpolarized light to the plane polarized light, and the second polarizer tests whether it is polarized, unpolarized or plane polarized. Now let us see some examples of polarization in everyday situation. The first picture, you can see the photographs, you can see thin film of water here. It reflects the sky. So we cannot see what is beneath the water. So the same photograph is taken by the same camera but adding a polarizing film to that, which is called filter. Then the film will be like this. You can see the reflections, the glare, everything is removed. So you are able to see the depth and see the floor. Thus the glare and the reflections are removed. You can see clearly the floor of the figure. Another example, here is a photograph. The first photograph shows a cupboard. So many instruments are there, but you can see on the glass some reflections are also there. So you cannot exactly see into the cupboard and tell what are all present. So the photograph of the cupboard is taken with a camera having a polarizing filter. The photograph will be like this. No glare, no reflections. You can clearly see into the cupboard. So thus the polarization will help us to see a clear picture which is having more clarity, and there is no glare at all, no reflections also. So a polarizing thin film eliminates all the glaze and the picture quality will be very good. This is our everyday experience. In everyday life, youngsters, everyone is very passionate to take many photographs. So if your camera having this polarizing filters, definitely it is little bit expensive, but the photographs taken will be very clear and having very good quality also. So let us see some more applications in daily life. Polarization applications, you can see imaging and display. Whatever you display in the display screens, definitely there will be a polarizer, and polarization principle is used in optical communication, in optical analysis, optical sensing. You can see when we wear glasses, they will ask whether this polarizing filter can be kept so that you can see things without glare. So that is that. This is the LCD TVs. Cameras definitely having some polarizing films as a filter. You can see wherever you use laser, if you have this polarizing filters, definitely whatever you do, the clarity will be more. And you can use it for material analysis, biomedical measurements. You can study about the microorganisms, the tissue, everything. And so with the help of a spectroscopic study, those instruments, that microscopes, if they have the polarizing filter, the structure can be very clearly seen in navigation and in astronomical detection and atmospheric studies. Definitely these polarizing technique is used. So let us see one by one. Why knowing polarization is important? If we know this phenomena, we can use it and we can get compromised to go for little high-end products, for example cameras or mobiles, so that whatever pictures, whatever study we make up will be very with the clarity we can take up. So polarized sunglasses. Polarized lenses reduce glare from surfaces like water, snow and roads, especially during summertime and all. We get a reflection from the roads, and which will make us to be confused. So if you use sunglasses, the glares from the floor of the road can be eliminated, and moreover the unwanted extra sun rays can be eliminated. What is needed alone can be given to the eyes, so that the vision will be very clear. Next, in photography also, just now I said that cameras will be using the polarizing filters, so that the picture taken will have very good image quality, color contrast and clarity. 3 factors. The picture taken will have good quality and good color contrast and also clarity. And we are all fond of to watch 3D movies. When we go to the theatre, they give us special spectacles. So when you wear the spectacles, help us introduces some factor there. That means it ensures that each eye sees a slightly different image, providing a 3-dimensional view experience. We can see into the depth, and we feel that 2-dimensional picture becomes a 3-dimensional picture. So it would be very real like. Then we have LCD screens. Nowadays our watches, our mobile screens and TV screens are all now converted into LCD screens to have more quality experience. When we watch movie on LCD screens, you feel that it's just happening in front of your eyes in reality. That means all the unwanted things will be eliminated. You can see that LCD screen, that LCD TV is a bit costly because the screen itself is very thin. It may be thin, but inside the screen you have so many thin films to make it very sleek and elegant. So you can see here in LCD screen also you will be using this polarizing filters. You can see a mirror here. In front of that you have a polarizing film which is having its optic axis parallel. And in front of the screen, the digital screen, you can see here another polarizing film with horizontal chosen directions. That is, optic axis is in the horizontal direction. Thus, wherever you use LCD screens, whether it's a watch or smartwatch or smart TV or smart mobile, everywhere definitely the polarizing phenomena is taken into consideration. In communication system also we use this technique of polarization. It is used in radio, satellite and television antennas to improve signal reception and transmission by reducing interference. Next one is microscopy and optical instruments. Polarized light is often used in scientific instruments such as polarizing microscopes to study materials like minerals and biological tissues, offering greater detail by reducing unwanted reflections. This is the polarizing microscope. If you keep any thin film having microorganisms or some minerals, through the eyepiece, if you view, you could study the crystal structure and the mineral structure, everything, so that you can classify the substances in a better way. Polarized light allows the measurement of optical properties of minerals and similar materials and can aid in the classification and identification of unknown substances. Right? So under the polarizing microscope you can see the structure. For the naked eye they will be just like powder like, or the organisms we may not be even able to see, but with the microscope having this polarizing film added, the picture quality will be very good. And even astronauts, the space suits which astronauts wear, there also some polarizing films will be attached, inserted in the cross position, so that unwanted sunlight can be avoided and astronaut safety can be preserved. So thus we find the simple phenomenon of light polarization has vast applications in our daily life. So learning this polarization helps us to understand what is happening in our life. It plays a significant role in various technologies and tools that we encounter in everyday life. By understanding how it works, we can appreciate its importance in enhancing vision, communication, and optical precision. So, polarization of light is a gift for us. I hope you have understood this little short discussion. I hope we will meet some other time with some other topic in physics which everyone could enjoy and appreciate the applications of physics in our daily life. Thank you, one and all.